So of course the biggest part of what you want to do here and what you guys will be able to do with this data, especially on your advanced field mapping course, is to actually analyze folds. Of course you first have to collect the data. You've got to collect as much data as possible, but very important is to take as many measurements as possible on the limbs of this fold. Bear in mind that you might not be able to see the fold where you are standing because it might be too big, so you will have to collect data throughout the field area. You will then plot them on the stereonet, and then very easy to do right from the beginning is plot this data as poles, especially if you've got more than one measurement. It's of no use of plotting them all as planes and then to try and convert them all as poles. So just start off with plotting them as poles instead. So let's see that we've got to, we'll just quickly do it so that you guys can see. I don't want to spend too much time here. So we've got one cluster of data points over here, okay, and we might have another cluster of data points over there, okay. Not the greatest colors, okay, the blue, but those represents data that you would have measured in the field. So what do I do? The first thing is that you've got to try and select, and of course you will do this with software packages and so forth. There is a way of doing it by hand, but we don't have time for this. You will want to try and pick the average of this aerial distribution of these poles, and that's again why we use the stereonet. So let's say in this case that average pole is over here for this cluster, and the average pole is somewhere there for this specific cluster. So the first thing that you can do is you can go and draw in these average planes for the average pole. Again, 90 degrees away, it's 10, 20, 30, 40, 50, 60, 70, 80, 90, and well, that's 100, that's 90. So we draw in that plane. Okay, we can of course go and do the same for the other cluster. We say that that is about the average pole here, so it's 10, 20, 30, 40, 50, 60, 70, 80, 90, and then we draw in that plane. Okay, so there we've got our two planes. You can of course go and determine the different direction and the strike, by taking this on, so that it intersects north and south on the great circle, and then read off the direction if you want to do so. But that's not what we want to do now. The first thing we want to try and get is the orientation of the fold axis or the hinge line, and that, if you would remember, is pretty much indicated by where these two planes intersect each other. So you take that intersection point to the east-west reference line, you make a little mark so that you can read off the direction, and you can count off the dip angle 10, 20, 30, 38 degrees. So we can call it the hinge line. We said that the dip angle is 38 degrees. You then take this back to north, stereonet, rotate it back to north. That's 180, 170, 160 degrees. 160 degrees. Okay, so that is the orientation of the hinge line. The second thing that you would want to know about this, of course, is the interlimb angle. And again, we know we can determine the angle between two planes by determining a plane that is 90 degrees to the intersection point. Okay, so we count away 90 degrees, 10, 20, 30, 40, 50, 60, 70, 80, 90 degrees, and we can then go and draw in this great circle. Okay, and it's along this great circle that you can then go and determine the angle between the two limbs of the fold. In this case would be 10, 20, 30, 40, 50, 60, 70, that's 76 plus 2, call it 78 degrees. So the interlimb angle is 76 degrees. So you can already use that to start and classifying this fold. Then of course you want to know the orientation of the actual plane. Okay, now there's two ways of doing it. The first prize is actually, of course, knowing what the actual the trace of the actual surface is, okay, or the actual trend. So if I just make a little sketch here of what we see in our fold, okay, is we see something like this, okay, in the field. So we could have read off that angle, and let's say that trace, the angle, remember, the direction of the trace would be, of course, somewhere in here, and let us just call it 174 degrees, okay, for argument's sake. That's the direction. Okay, remember it's got no plunge to it because it's the intersection of the Earth's surface. So what we do is, again, we take our stereonet to north and we go and we count off 174 degrees. There's 180, that's 170, that's 174 degrees. Now to determine this orientation of the actual plane, we of course have to rotate our stereonet until the intersection point and that point falls on the same great circle, okay, and it's somewhere around there. So we can now go and draw in this great circle, okay. We stay on that great circle, try to look past the camera, and this is going to be the orientation of the actual surface. So you can of course go and determine, first of all, the dip direction, or the direction on which its actual surface is dipping, but you can also determine the angle at which it's dipping, 10, 20, 30, 40, 50, 60, 70 degrees. Okay, so the actual plane is 70 degrees the dip angle, and the direction is at about 84 degrees. So now you already know which direction the hinge line is pointing. You know the angle between the limbs. You also know the orientation of the actual plane, okay, and that data is a lot of data that you can use to go and classify your fold. But say you didn't know what the orientation of this trace of the actual surface is, okay, how would you do it then? Well, it's not the greatest, but it's usually better than nothing. But you can get a good estimation by going and taking again this plane from which you determine the interlimb angle, and you go and find the halfway point, 10, 20, 30, 40, 50, 60, 70. We said it was 76 degrees or 78 degrees, which of course will make it 38 degrees. So let's go 10, 20, 30, 38 degrees, okay? And now if you rotate that point and the intersection until they fall onto the same great circle, you can go and draw in this inferred orientation of the actual plane. And you see it's a little bit different from what we had originally, okay? It's dipping towards a different side and so forth. So it's always better to try and determine this actual trend instead of going the easy way and using the halfway point. It gives you a good indication, but it's not 100% correct. The best way is to actually look at the map which you've produced, determine the orientation of the actual trend, measure that direction, okay? In that direction you use, remember this direction doesn't have a dip angle, so it will fall on the primitive circle. And this way you can go very far to actually classify your fold.